Have you ever peered into the future of AI and wondered, how are those incredibly sophisticated large language models actually put through their paces? It's definitely not like checking if 2 plus 2 equals 4 anymore.
No, not at all. It's a whole new ballgame, really.
Yeah.
Requires entirely different rules, different approaches.
You're right.
Yeah.
Today we're taking a deep dive into LLM evaluation. And this isn't just about finding, stray bugs. It's more like a foundational discipline for building AI that is truly reliable, safe, and, well, genuinely intelligent.
Absolutely crucial.
Our mission here is to give you a real shortcut to understanding this complex but absolutely critical field. We're going to unpack why LLM evaluation is such a radical departure from traditional software testing, explore the ingenious methods being used, and then reveal the biggest challenges and the future horizons in this rapidly evolving landscape.
It's moving so fast.
It really is. Hopefully you'll walk away not just informed, but with a new appreciation for the engineering rigor behind this whole AI revolution. And for this deep dive, we've been immersing ourselves in the comprehensive guide to large language model evaluation, from core principles to frontier challenges, which lays out all the foundational concepts really well.
It's a great resource.
So let's unpack this term evil that's thrown around so much in the AI world. What does it actually mean, and why is it so different for these large language models?
Right. So at its core, evil is the systematic process of assessing an AI model's performance, its quality, its safety, against predefined criteria. But here's the kicker, the crucial difference. Unlike traditional software, which is deterministic, same input, you always get the same exact output. LLMs are probabilistic, meaning you ask an LLM the same question twice, you might get two slightly different yet maybe equally valid responses. And this non-determinism, it fundamentally breaks traditional exact match testing.
I can see that. If add 2 each 2 always has to return 4, that's straightforward to test. Easy. But if I ask an LLM to write a poem about the ocean, and it gives me 2 beautiful but different poems, how do I test that? Which one is correct?
Exactly, that's the heart of it. The goal isn't to verify one single specific output. Instead, it's about ensuring the LLM's behavior consistently remains within a range of acceptable parameters, meeting standards of quality, relevance, safety.
Okay.
Its ultimate purpose, really, is to provide objective, data-driven decision-making for LLM development. It transforms the entire process from guesswork or intuition into rigorous engineering. It guides everything from prompt engineering all the way to model selection and deployment.
And why is this evaluation such a cornerstone then? Beyond just making sure the model works, what are the bigger stakes here?
Oh, its importance really can't be overstated.
Yeah.
I mean, first, there's just reliability and performance. Any change you make, maybe a tweak to a prompt, a different ag data source, even an update to the underlying model, it can have unpredictable effects.
Right.
Evils give you quantitative data to measure that impact, to drive improvements, and, crucially, to prevent performance regressions. Think of it as that critical feedback loop. It ensures your AI doesn't suddenly, take a nosedive or start behaving erratically.
It's like a consistent health check for your AI, catching problems before they become actual crises.
Precisely. And second, it's absolutely fundamental for ensuring safety and trust. LLMs, if they're left unchecked, can generate all sorts of problematic content, harmful, biased, factually incorrect stuff, or even accidentally leak sensitive private info.
Yeah, you hear about that.
So rigorous safety evils, things like adversarial red teaming and bias testing, they proactively identify and mitigate these risks. This is just non-negotiable for building user trust and deploying AI responsibly out there in the real world.
That makes perfect sense. I mean, with new models popping up almost daily, each claiming they're the best, how does a company even begin to choose which one to use?
That's the third critical function, navigating the LLM landscape.
Yeah.
Evils provide a standardized, empirical way for organizations to cut through all the marketing hype,
Right.
They let you make informed, evidence-based decisions about which model offers the optimal balance of performance, cost, and safety for their specific real-world use cases. It helps you pick the right tool for your job, not just the one making the most noise.
Okay, so this all points to a pretty radical shift in how we actually build software, doesn't it?
Yeah.
The guide talks about a paradigm shift from traditional machine learning evaluation. What are the big differences in the sort of philosophy of development?
The shift is profound, yeah. Fundamentally, it's moving from discriminative tasks to generative ones. Traditional ML models are typically discriminative, think classifiers or regressors. They map an input to a structured, well-defined output, like a class label or a numerical score.
Like a multiple choice test.
Exactly. Their evaluation uses clear metrics like accuracy, precision, you have unambiguous ground truth labels. It's pretty straightforward.
But LLMs are generative. They create open-ended, unstructured text across this vast, almost infinite output space. That's a totally different ballgame.
It truly is. Their creative capacity, as the guide calls it, means those traditional exact match metrics just fall short. And this introduces subjectivity in a big way. For many LLM tasks like summarization or creative writing, there's often no single correct answer.
Right.
Quality is subjective, it's context dependent. So that necessitates methods that can handle nuance, like human evaluation or these more sophisticated model-based scoring techniques.
And the scale, too.
Oh, the scale and complexity are immense. Traditional ML models are simpler, more interpretable. LLMs are often black boxes with billions, sometimes trillions of parameters. Their internal reasoning is opaque. So evaluation has to focus on the observable output behavior.
Oh, okay.
And they bring totally unique issues like benchmark data contaminations is a huge one. It's where the model might have inadvertently seen the test questions during its training phase.
Oh, wow. So it just memorized the answers.
Exactly, leading to falsely inflated scores that reflect memorization, not true generalization or understanding. It's a major problem for the integrity of evaluations.
And here's where it gets really interesting, I think, especially for developers and for anyone who's ever built software. The guide talks about this philosophical shift in development, from test-driven development, TDD, to evaluation-driven development, EDD.
Yeah.
This sounds like a complete rethink. How does that actually work in practice?
It's a fundamental flip. TDD is perfect for deterministic systems, right? You write a failing test first, then code to make it pass. Add 2 into always returns 4. Simple. But as we've said, an LLM summarizing an article will give you slightly different yet perfectly valid summaries each time. TDD, as we traditionally know it, just breaks down for these probabilistic models.
So EDD is specifically tailored for this inherent uncertainty. Right. Instead of a rigid pass-fail, you're looking at something more nuanced.
That's precisely right. Instead of asserting an exact output string, you create an eval that scores the output against a rubric of desired qualities. Things like factual consistency, conciseness, maybe the tone of voice.
Okay.
The assertion then becomes about the score itself. For example, you might assert that factual consistency score 0.9.
Okay.
This elevates the entire evaluation suite, the prompts, the data sets, the scoring functions. It makes them a first-class version-controlled artifact within your codebase, just as important as the application logic itself. It's really a new way to build software, architected around managing this uncertainty, like designing a bridge for an earthquake zone instead of just for a static load.
That makes so much sense conceptually. So how does this new evaluation philosophy actually play out in the real world? The guide talks about integrating evals into the entire LLM application lifecycle, what people often call LLMOP.
Yeah.
It's not just a final check, right? It's a constant companion.
Exactly. It's continuous, it's iterative, deeply integrated. You can kind of break it down into 3 main stages. First, there's stage 1, initialization and experimentation. This is pre-production. You're defining the use case, maybe collecting a small golden data set, crafting initial prompts.
Getting started.
Yeah, evaluation here is mostly qualitative and really rapid. Lots of informal vibe testing, does this feel right? And maybe some low-complexity code-based checks like, is the output valid JSON? The goal is super quick iteration, just getting a feel for things.
So you're just getting a sense of direction, making sure you're not completely off track, like a quick prototype phase.
Precisely. Then you move into stage 2, evaluation and refinement. This is more like staging or pre-deployment. Now, the system gets assessed against a much larger, more comprehensive data set. This includes both happy paths, the ideal inputs, and also adversarial inputs, specifically designed to stress test robustness and safety.
Trying to break it.
Basically, yeah. Evaluation here becomes quantitative and structured. You're using automated metrics, maybe LLM-as-a-judge, perhaps some small-scale human evaluations to benchmark performance and, crucially, identify any regressions before you launch.
And once it's actually out there in the wild, in production, what happens then? Does evaluation stop?
Not at all. That's stage 3, production, post-deployment. Evaluation shifts to continuous online monitoring. This includes classic operational metrics, latency, cost, but crucially also user interaction data.
Like feedback.
Exactly. Explicit feedback, like thumbs up, thumbs down buttons, or implicit feedback, like noticing when a user has to rephrase a query because the first answer wasn't helpful. This real-world feedback is absolute gold. It uncovers unexpected failure modes, real user expectations, and then channels those insights directly back into the development cycle.
Okay, this really sounds like evaluation-driven development in full swing then. What's the biggest benefit you see for a team adopting this as a core philosophy?
I think one of the most powerful aspects of EDD is how it replaces subjective gut feelings, just thinking something is better, with objective, data-driven measurement to guide the whole development process.
Right.
You create and maintain this gold standard evaluation set, and your progress is measured by performance against that set. Failures aren't just annoying bugs, they directly inform and prioritize the very next development cycle.
So the workflow becomes something like create your initial evils, launch the feature, monitor for real-world failures, add those real-world failure examples back into your evil set, refine the system specifically to address those, then relaunch, and just repeat that loop.
Exactly. That's the core loop. The key benefit is it provides a structured methodology for building truly reliable LLM applications. Teams can ship features with much more confidence, they can catch regressions before they impact lots of users, and they have clear quantitative measures of progress.
That makes sense.
And this integration creates what the guide calls a data flywheel. It's a really powerful concept. When your LLM application is in production, it's constantly encountering new real-world inputs, new edge cases.
Things you didn't anticipate.
Exactly. A mature EDD process dictates that these new failure cases are systematically captured and added back into the core evaluation dataset. So with each cycle, this dataset becomes richer, more diverse, more representative of the real world.
So this evolving evaluation dataset becomes an invaluable proprietary corporate asset. It's like a competitive advantage that actually compounds over time.
That's the real aha moment, I think. It enables the organization to build a demonstrably superior product, which then attracts more users, which generates more data, which further improves the evil set. It becomes a sustainable competitive advantage. It's a truly virtuous cycle of continuous improvement.
That's brilliant, actually. Now let's get into the nitty-gritty. Let's talk about the actual tools in the evaluator's toolkit. Given all this complexity we've been discussing, where do you even begin to measure something like LLM output?
Yeah, good question. You typically start with automated metrics. They're fast, they're scalable, reproducible. They form a quantitative baseline. Within that, you have reference-based metrics. These compare the generated text to some human-written reference text. Common ones are BLEU, which measures the precision of word sequences, or n-grams. It's often used in machine translation.
Okay.
Then there's ROUGE, ROUGE, which focuses more on the recall of n-grams, primarily used for text summarization. And Meteor, which is a bit more sophisticated. It accounts for synonyms, stemmed words.
Yeah.
It often correlates a bit better with human judgment than the simpler ones.
But I'm guessing these aren't perfect, right? Especially
Yeah.
for something as creative or nuanced as an LLM might produce. Comparing word overlap feels limited.
You're spot on. That's a crucial limitation. These purely lexical overlap metrics often correlate pretty poorly with human judgment when it comes to semantic understanding or creativity. And their validity also depends entirely on the quality of the reference text you're comparing against. Garbage in, garbage out, basically.
Right.
So that's where reference-free and learned metrics come into play. They try to overcome these limitations. Perplexity, for example, measures how surprised the model is by a piece of text, which can indicate its coherence and fluency.
Interesting.
BERT score uses contextual embeddings from models like BERT to measure semantic similarity. It can recognize, for example, that king and monarch are similar even though the words are different.
Much smarter.
Yeah. And Comet is actually a neural network that's been trained specifically on human ratings of translation quality. It's shown very high correlation with human evaluations, especially for machine translation. There's also a lot of active research into metrics that need no human-written reference at all, like methods trying to assess logical consistency between a source document and a generated summary directly.
Okay, automated metrics are one piece. Then we have standardized benchmarks. We hear about these all the time when new big models are announced, right? Model X achieves state-of-the-art on benchmark Y. What are they, and what role do they really play?
Right, they're essentially the academic proving grounds. Collections of datasets and tasks designed to test specific LLM capabilities in a standardized way. You have general capabilities benchmarks like MMLU, that's massive multitask language understanding. It evaluates broad world knowledge and problem solving across like 57 diverse subjects, math, history, law, from elementary up to professional level.
Wow.
And HelloSwag, which tests common sense reasoning. It asks the model to choose the most logically plausible ending to a given scenario.
Kind of like a common sense test. And then there are more specialized benchmarks for specific skills.
Absolutely. Human Eval assesses code generation ability using about 164 Python programming problems, measuring functional correctness. Truthful QA measures a model's truthfulness and its ability to avoid generating misinformation. It uses adversarially crafted, misleading questions across maybe 38 categories, and it's often scored by another powerful LLM, sometimes called a GPT judge.
Using an LLM to score another LLM's truthfulness.
Yeah. And there's a BFCL, the Berkeley Function Calling Leaderboard, that evaluates how proficient a model is at calling external functions or APIs, testing if it selects the correct tool and provides the right parameters.
But the guide gives us a pretty crucial warning about these benchmarks.
Mm.
They're not the whole story, and they have significant problems.
Yes, this is a really critical point for anyone relying on these scores. While benchmarks are useful, they often have a restricted scope. They might test only a narrow skill. They also tend to have a short lifespan because models quickly solve them or get optimized for them, and sometimes they lack direct real-world applicability.
But the biggest issue.
The biggest, most critical issue, the real elephant in the room, is benchmark data contamination. We touched on it before. This happens when the public benchmark test data inadvertently gets included in a model's massive pre-training data set.
So the model has already seen the exam questions, essentially.
Precisely. When that happens, high scores reflect memorization, not genuine generalization or understanding. It's a pervasive and significant threat to valid evaluation. It can lead to misleading conclusions about which models are truly capable, causing wasted effort and resources.
Okay, so if automated metrics have limits and benchmarks can be contaminated, what's considered the gold standard for getting at those really nuanced aspects of LLM performance?
Despite all the automated advances, human evaluation, often called human-in-the-loop, HITL, is still widely considered the gold standard for assessing those nuanced subjective qualities. Things like creativity, persuasiveness, helpfulness, or even the tone of the output.
How did that work, typically?
Well, common techniques include things like Likert scales, where human raters score outputs on, say, a 1 to 5 scale for helpfulness. Simple, but sometimes susceptible to writer biases or inconsistency. Another popular method is pairwise comparison. You show the evaluator 2 different outputs generated for the same input prompt, and just ask them to choose which one is better according to some criteria. This is often easier and more consistent for humans than assigning an absolute score.
And how do humans directly feedback into improving the models themselves, beyond just providing a score after the fact?
That's where reinforcement learning from human feedback, or RLHF, comes in. It's a really powerful application of human evaluation that directly integrates human preferences into the model training process itself.
How does that work?
It's typically a multi-stage process. First, you collect human preference data. Humans compare 2 or more LLM responses to a given prompt and select the one they prefer. Then, this preference data is used to train a reward model. This is another model that learns to predict which responses humans are likely to prefer. It learns to assign a score reflecting human preference.
Okay.
Finally, the original LLM is fine-tuned using reinforcement learning techniques, where the reward model provides the signal. The LLM is essentially trained to maximize the reward score it gets from the reward model, which steers it towards generating outputs that are more aligned with what humans actually prefer.
That makes sense. That was central to models like ChatGPT, right?
Absolutely. It was a key technique behind models like InstructGPT and the early versions of ChatGPT, making them feel much more helpful and aligned.
So human input is crucial, the gold standard, but it sounds incredibly expensive and time-consuming to do at scale. This leads us nicely to the next idea. LLM as a judge. What's the promise here? Using one super smart LLM to evaluate another one.
Exactly. It's an exciting approach that directly tries to address the cost and scalability limitations of large-scale human evaluation. The idea is you use a highly capable LLM, maybe something like GPT-4o or Claude 3.5 Sonnet, to automate these subjective evaluations.
How do you tell the judge LLM what to do?
You craft a detailed evaluation prompt. This prompt instructs the judge LLM on the specific criteria it should use, the aspects it should focus on, and the format you want the evaluation output in, like a score, a critique, a comparison. It can perform various types of evaluation. scoring a single output against a rubric, doing pairwise comparisons like humans do, or even reference-guided scoring. The last one is especially useful for awake systems, checking if the generated answer is faithful to the provided source documents.
Okay, this sounds almost too good to be true. Using AI to grade AI's subjective qualities. I'm guessing there are some pretty significant caveats or dangers here.
You're absolutely right to be cautious. LLM judges are definitely not infallible, and it's really important to understand their limitations. They have their own inherent biases, for example. There's verbosity bias, where they might tend to prefer longer, more detailed answers, even if they aren't better. There's positional bias, where they might favor the first response they see in a pairwise comparison. And maybe even self-enhancement bias, where a judge model might subtly prefer outputs generated by models from its own family or architecture.
Okay. What else?
Perhaps the most concerning risk is creating hallucination echo chambers.
What does that mean?
Well, the judge LLM itself can hallucinate or make errors, right? So you could have a situation where a judge LLM validates a hallucinated or incorrect output from the model being evaluated, essentially reinforcing the error instead of catching it.
Yikes. That's not good.
No. Plus, these LLM judges are highly sensitive to the evaluation prompt you give them. Even minor changes in the wording of the prompt can significantly alter the evaluation results.
This raises a really interesting, almost philosophical question. If we're using an LLM to evaluate our application, how do we evaluate the evaluator itself? It feels a bit like evaluation inception.
It is. It's a genuinely recursive problem, and it means you need a multi-layered strategy. You can't just blindly trust the LLM judge. What you typically do is create a small, carefully human-labeled ground truth dataset specifically for the judge. These are evaluation tasks where you already know the correct assessment based on human consensus.
Right.
Then you run your LLM judge on this ground truth set and compare its scores or judgments to the human labels. This allows you to measure the judge's accuracy, identify its specific biases, like that verbosity bias, and calculate its correlation with human judgment. So yeah, building a reliable LLM evaluation system, including the judge, is in itself a rigorous LM development task. You have to evaluate your evaluator.
Okay, shifting gears slightly. Beyond just performance and quality, safety is obviously a monumental concern in AI. What are the key evaluation methods specifically designed to probe for weaknesses and ensure responsible deployment? What keeps developers up at night when they think about these models in the wild?
Yeah, deploying LLMs carries significant risks, no doubt about it. Generating harmful content, perpetuating biases, spreading misinformation. Responsible development must include rigorous evaluations to proactively uncover these potential harms. A key technique here is red teaming. It's borrowed directly from cybersecurity. It involves intentionally crafting adversarial inputs specifically designed to try and elicit problematic outputs or behaviors to find vulnerabilities.
How does that work?
You start with threat modeling, thinking like an attacker. How might someone try to jailbreak the model's safety constraints? How could they perform prompt injection? Could they extract sensitive data? Then, based on those threats, you generate a diverse set of potentially malicious prompts and evaluate how the model responds. The goal here isn't necessarily to get a quantitative score, but to explore the possibility of failure. One successful exploit, one instance where the red team gets the model to do something harmful, signals a significant weakness that needs fixing.
So you're actively, intentionally trying to break it in every conceivable harmful way. What about bias? We know bias can easily creep into these models trained on web data.
That's another huge area. Systematic evaluation of bias and fairness is absolutely critical because LLMs trained on vast amounts of internet text inevitably reflect and can even amplify existing societal biases.
Where's the bias come from?
It can stem from the training data itself, the model architecture choices, or even subtle biases introduced by the human reviewers during RLHF. Evaluation here uses various fairness metrics, like demographic parity, checking if outcomes are similar across different groups, or counterfactual fairness, checking if changing a sensitive attribute like race or gender would change the outcome. There are also specialized bias metrics. Some are embedding-based, like WHEAT, which looks for stereotypical associations between words like doctor with man versus woman. Others analyze the probability of generating biased text, or directly measure the toxicity of generated content across different demographic groups. And we also use bias benchmarks, like Crow's pairs, which contains sentence pairs designed specifically to test for stereotypical associations. The goal is to detect and quantify these biases so they can be mitigated.
And then there are hallucinations, the frustrating tendency of LLMs to just make things up. That seems like a really persistent challenge. How do we even quantify that, let alone mitigate it?
Hallucinations are definitely a major headache, where LLMs generate factually incorrect, nonsensical, or unfaithful content. This can range from subtle inaccuracies to completely inventing sources or studies, which poses severe risks depending on the application.
And how do you evaluate for that?
For retrieval augmented generation, RAG systems, which are supposed to base their answers on retrieved documents, a common technique is faithfulness evaluation. You break the LLM's generated answer down into individual claims or statements. Then you use another LLM, acting as a judge, to verify each claim against the original source documents provided to the first LLM. Did it accurately reflect the source, or did it invent something?
Okay, checking against the source. What about models that generate content without a specific source, like describing an image?
For large vision language models, there's a technique called POPE, that's polling-based object probing evaluation. It cleverly converts the problem of object hallucination, describing objects that aren't actually present in an image, into a simple yes-no classification task, making it easier to quantify how often the model sees things that aren't there. Another approach gaining traction is integrating knowledge graphs. These are external, structured sources of factual information. By grounding the LLM's outputs against a reliable knowledge graph, you can verify claims and potentially reduce hallucinations significantly.
This all sounds like a constant balancing act, though. The guide talks about a fundamental tension, a trade-off, capability versus controllability, or what they call the alignment tax. This sounds like a really tricky strategic dilemma for developers.
It absolutely is. This is one of the fundamental tensions in AI safety and development right now. Techniques designed to make models safer, things like RLHF, or implementing strict guardrails to prevent harmful outputs can, if they're applied too bluntly or aggressively, inadvertently diminish the model's useful capabilities. Its helpfulness, its creativity, its ability to follow complex instructions.
How so? Give me an example.
Imagine a model that becomes overly cautious due to strict safety tuning. It might start refusing to answer perfectly valid, harmless questions just because they happen to be related to a sensitive topic, even if the question itself isn't problematic. That's the alignment tax, the potential cost and capability you pay for increased safety or alignment.
So you have to evaluate both together.
Exactly. Safety evaluations must be run in conjunction with capability evaluations to understand the full impact of any safety intervention. It forces a core strategic consideration. How much capability are you willing to potentially sacrifice for a given level of safety? And what are the real-world implications of that trade-off for your specific application? It's not an easy decision.
That's a fascinating and genuinely tough strategic decision. And speaking of increasing capability, LLMs are rapidly evolving into these more autonomous agent systems that can reason, plan, and use external tools to achieve complex goals with minimal human intervention. This capability leap must bring a corresponding leap in evaluation complexity, right? What's the unique challenge of evaluating these agentic systems?
Oh, it's a significant jump, absolutely. We're no longer just evaluating a single static text output like a summary or an answer. We're evaluating a dynamic, multi-step process or trajectory, the sequence of thoughts, actions, and observations the agent takes to achieve a goal.
Why is that so much harder?
Several reasons. First, complexity. Agents are complex systems with multiple interacting components, the core LLM doing the reasoning, some kind of memory module, a planning component, the tools it uses. Failure can occur anywhere along that chain. Second, error propagation. A small error early in the agent's reasoning or planning chain can cascade and magnify dramatically, leading to complete task failure down the line, even if later steps are correct.
Right, the whole thing derails.
Exactly. Third, high non-determinism. Agent behavior can be highly variable, influenced by its memory state, real-time outputs from the tools it calls, and the inherent stochasticity of the LLM itself. Running the same agent task twice might result in very different paths. So the focus of evaluation must shift from just looking at the final answer to assessing the quality and correctness of the entire sequence of thoughts and actions the agent took.
So how do we even begin to assess that multi-step reasoning and planning process within an agent? That sounds tough.
It is tough. We start by looking at the reasoning frameworks these agents employ. Many agents use frameworks like chain of thought, CFD, to generate explicit reasoning steps before acting, or React, which interleaves steps of thought, action, and observation, or even tree of thoughts, CFT, which explores multiple possible reasoning paths concurrently.
And the metrics change too.
Yes, the metrics have to adapt. We still care about task completion rate or goal completion rate. Did the agent ultimately achieve the high-level goal it was given? But we also need metrics that evaluate the process itself. Things like reasoning relevancy are the agent's generated thoughts logically connected to the user's request and the current step. And reasoning coherence does the agent's plan or sequence of thoughts flow logically. There's also an interesting framework called PREACT, where the agent first generates a complete multi-step execution plan, which is then evaluated and potentially refined before execution begins. This allows for more comprehensive evaluation at both the individual step level and the end-to-end plan level.
And what about their ability to actually use external tools like calculators or web search APIs? That's a huge part of what makes agents so powerful compared to just a bare LLM.
Evaluating tool use is critical, yeah. It involves looking at both correctness and efficiency. For correctness, you ask, did the agent choose the correct tool for the job at hand? Did it try to use a calculator for arithmetic? Or did it mistakenly call a web search? And importantly, did it call the chosen tool with the correct arguments or parameters? For example, if it needed weather, did it call get weather, city Paris, or did it mess up the parameter name or value?
And efficiency.
Efficiency looks at whether the agent used tools effectively. Metrics here might include redundant tool usage. Did it make tool calls that weren't actually necessary to solve the problem? Or tool frequency, did it call the same tool repeatedly when once would have sufficed? You want agents to be effective and efficient.
Now, here's an aha moment I had when I was reading the guide. It says the challenges in evaluating these AI agents directly mirror long-standing problems in the field of robotics. That's not a connection I would have immediately made. How so?
It's a really insightful connection, isn't it? Think about it. An LLM agent, much like a physical robot operating in the world, essentially follows a plan, act, observe loop within its environment, even if that environment is digital.
Okay, I see that.
So many of the challenges are analogous. How do you evaluate the quality of a plan? How do you measure task success when the environment is dynamic and uncertain? How do you account for perception errors or failed actions? These are core problems in robotics evaluation. The guide suggests that the future of agent evaluation will likely borrow heavily from robotics, incorporating concepts like path efficiency, robustness to failure, and goal completion under uncertainty.
And how might that look in practice?
This strongly points towards more simulation-based evaluation, testing AI agents in complex, sandbox digital environments where you can control variables, inject faults, and measure performance across a wide range of scenarios. Much like how autonomous vehicles are extensively tested in virtual worlds before they ever drive on a real road.
Wow. So evaluating agents requires building sophisticated virtual worlds for them.
Potentially, yes. For complex agents, that's likely where the field is heading. It represents a huge leap in the complexity and sophistication needed for evaluation infrastructure. It's almost like building a digital wind tunnel or a flight simulator, but for AI agents.
That's fascinating. Okay, with all these complex needs and evolving methodologies we've discussed, what does the practitioner's ecosystem actually look like today? What are some of the popular tools and frameworks out there that help developers do LLM evaluation in the real world?
Yeah, the ecosystem is definitely vibrant and growing super fast, reflecting how important this has become. Choosing the right tool really depends on your specific needs and workflow. One prominent example is Langsmith, which comes from LangChain. It's positioned as a comprehensive platform for the entire lifecycle building, debugging, and monitoring LLM applications, and it has strong evaluation capabilities built right in.
What's its key strength for evaluation?
I think its core value proposition is tightly integrating tracing, seeing exactly what your LLM app did, with evaluation. It allows you to easily identify failures happening in production from those traces and then immediately turn those failures into new evaluation datasets to drive improvement. That feedback loop we talked about.
That sounds incredibly powerful, capturing real-world failures and making them test cases automatically.
Exactly. Then, for more foundational metrics, there's Hugging Face Evaluate. This is a key open source library that provides easy, standardized access to dozens of common metrics like BLEU, ROUGE, Meteor, BERT score, etc. It's really ideal for researchers or developers who need standard, reproducible metrics quickly and easily. DeepEvil is another interesting open source framework. It positions itself more as a unit testing framework specifically for LLMs, designed to integrate smoothly into CI/CD pipelines. It offers a pretty rich suite of pre-built metrics covering things like RAG performance, responsible AI checks, bias, toxicity, and even metrics for evaluating agentic reasoning steps.
So more focused on automated testing during development. What about tools for larger teams or more enterprise-focused development workflows?
Right. Human Loop is a good example of an enterprise-focused platform. It's designed for building and managing production-grade LLM applications, with a strong emphasis on collaboration features. It offers user-friendly interfaces for things like prompt management, A/B testing different prompts or models, and crucially, collecting and managing user feedback. It supports using AI, code-based rules, or actual humans as graders for evaluations. And for teams working heavily with retrieval-augmented generation systems, there's RAGAS. This is a specialized open-source framework that provides metrics tailored specifically for evaluating RGRE pipelines, things like faithfulness. Does the answer stick to the retrieved context? Context precision, is the retrieved context relevant? And answer relevancy.
So quite a range of tools depending on your focus.
Definitely. This array of tools really highlights how developers are tackling evaluation, from integrating it deeply into continuous development pipelines to building collaborative platforms for managing prompts, tests, and feedback across teams.
Now let's turn to the really tough stuff, the critical challenges. This field is still grappling with some fundamental unsolved issues that the guide argues are leading to a kind of trust crisis in LLM evaluation. What do you see as the most significant threat to reliable measurement right now?
Without a doubt, the most significant and pervasive threat is the issue we keep coming back to: benchmark data contamination.
Models seeing the test questions during training.
Exactly. It happens when data from public benchmarks, the very tests used to measure progress, inadvertently gets included in a model's massive pre-training dataset. This contamination can be direct, like verbatim copies of questions and answers. It can be semantic, where the concepts or paraphrased versions are present. Or even just informational, like discussions about the benchmark tasks found on the web.
And the impact.
The impact is severe. It means high scores on these benchmarks might just reflect memorization, not genuine learning or generalization ability. This leads to incorrect scientific conclusions about model capabilities, it misleads the entire community, and it causes organizations to potentially misallocate huge resources, chasing inflated scores or adopting models that aren't actually as good as they seem.
Are people trying to detect this?
Oh yes, it's an active area of research. There are methods ranging from simple enneagram overlap checks, looking for identical phrases, to more sophisticated statistical methods. One mentioned in the guide is ConStat, which tries to detect artificially inflated performance on a benchmark by comparing a model's performance on potentially contaminated questions versus clean ones. But it's a really hard problem to solve completely.
And what about the fact that many of the most powerful models are proprietary and constantly being updated behind closed doors? That seems like it would create a huge headache for trying to replicate results.
It absolutely does. That's another major challenge. Contributing to this trust crisis, the crisis of replicability and model drift. When proprietary models from the big labs are constantly updated, often without public notice or versioning, it makes scientific experiments incredibly difficult, if not impossible, to replicate accurately. The underlying model you're testing against is effectively a moving target.
Right. Your results from last month might not hold true today.
Exactly. And related to that is model drift in production. Even if a model is static, its performance on real-world tasks can degrade over time, simply because the patterns in user queries or the nature of the input data shifts. This necessitates continuous online evaluation and potentially periodic retraining or fine-tuning just to maintain performance.
And the persistent problem of subjectivity we touched on earlier, that must still be a huge underlying hurdle, right? The fact that for many tasks, there's no single right answer.
It absolutely is. For many important generative tasks, writing, summarizing, brainstorming, there simply is no single objectively correct ground truth output. This fundamental problem continually drives the need for expensive, scalable human evaluation and fuels the ongoing search for more advanced, nuanced, automated, or semi-automated techniques like LLM-as-a-judge, despite their own limitations.
So putting it all together, unreliable benchmarks because of contamination, models that are moving targets making replication hard, and the inherent subjectivity of many tasks. It really does sound like a potential trust crisis.
It does. It erodes trust in the evaluation results we see. This forces a necessary cultural shift in the field, moving beyond just looking at a single leaderboard score. We need to start asking more critical, contextual questions. Okay, this model was evaluated, but on what data? Was that data potentially contaminated? By whom was it evaluated? Humans, another LLM? And for what specific purpose or capability was this evaluation designed? The future, I think, is less about chasing a single score and more about constructing a comprehensive, transparent, evidence-based argument for a model's fitness for a particular purpose in a particular context.
That makes a lot of sense. Looking ahead then with all these challenges, how is the future of LLM evaluation evolving to try and meet them? What's on the horizon? What are the exciting new directions?
Well, it's evolving as rapidly as the models themselves, thankfully. We're definitely seeing a move beyond relying solely on static benchmarks. Some emerging methodologies include things like agentic evaluation pipelines. This is the idea of using sophisticated AI agents to autonomously evaluate other AI systems. These evaluator agents could perform multi-step reasoning, do automated fact-checking against external sources, or even engage in interactive dialogue to probe the system under test.
Using AI to test AI more deeply.
Exactly. There's also interest in game-based assessment, creating controlled, simulated environments, perhaps like simple games with clear rules and objectives, to test more integrated capabilities like strategic planning, reasoning under uncertainty, and tool use in dynamic contexts. And for really high-stakes applications, like in finance, law, or medicine, we'll likely see more emphasis on simulation and longer-term evaluation, running models not just on single prompts, but in extended simulations that mimic real-world usage over time to try and reveal emergent properties, biases, or safety risks that might not be apparent in short, isolated interactions.
So moving towards more holistic and definitely more specialized evaluations tailored for specific use cases and domains.
Precisely. There's a clear trend towards creating holistic, domain-specific benchmarks, moving away from the limitations of one-size-fits-all general-purpose benchmarks like MMLU. A great example highlighted in the guide is MedHelm, which is a benchmark specifically designed for healthcare applications. It was developed in close collaboration with clinicians, and it uses a multi-metric approach designed to capture actual clinical utility, not just language understanding in a vacuum.
That makes sense.
We'll see this trend replicate across other regulated or highly specialized fields: toxicology, legal reasoning, financial analysis. They'll require equally specialized, carefully constructed evaluation suites developed with domain experts.
And what about the most, perhaps, forward-looking or even slightly mind-bending development in evaluation?
I think perhaps the most forward-looking idea discussed is the rise of LLM psychometrics.
Psychometrics, like for humans, applied to AI.
Exactly. It's a nascent, new, interdisciplinary field that aims to apply the principles and techniques of psychometrics, which is the science of measuring psychological constructs like intelligence, personality, reasoning ability in humans to large language models.
Why would we do that?
The rationale is that as these LLMs exhibit increasingly sophisticated, sometimes human-like cognitive capabilities, we need evaluation tools that go beyond just measuring performance on specific tasks. We need ways to potentially measure more abstract underlying traits like their reasoning ability across different domains, their creative potential, their capacity for ethical judgment, maybe even aspects related to personality or alignment with human values.
That sounds ambitious.
It's incredibly ambitious, and it really requires deep collaboration between computer scientists, cognitive psychologists, linguists, and social scientists.
So if we follow that whole trajectory we've discussed, we started by evaluating the actual text the LLM generated. Then we moved towards evaluating the process, looking at the intermediate steps, the reasoning, the tool calls, especially with agents. And the ultimate destination, maybe enabled by something like LLM psychometrics, is evaluating the entity itself, assessing the underlying stable cognitive properties of the model.
That's exactly the evolutionary trajectory the guide suggests. It's a shift in focus from output to process to potentially the underlying properties of the AI itself. In the future, maybe before deploying a powerful AI in a critical role, we might actually subject it to a comprehensive psychological profile or a cognitive assessment, not unlike how we assess humans for certain jobs. It's a truly fascinating and perhaps slightly unnerving shift in how we might come to understand and measure these increasingly complex artificial minds.
Wow. Okay. We've certainly covered a lot of ground. We've journeyed from just defining what eval even means for LLMs and seeing how it fundamentally breaks traditional software testing paradigms, through exploring the diverse toolkit of methods, from automated metrics and benchmarks to human feedback like RLHF and the intriguing, if flawed, LLM-as-a-judge.
Yeah.
We've navigated some really critical challenges, especially that pervasive issue of data contamination and the crisis of trust it fuels. And we've peered into a fascinating future, looking at agentic evaluations, domain-specific benchmarks, and even this idea of LLM psychometrics. It's a lot to take in.
It really is, and hopefully this deep dive illustrates that this isn't just, technical jargon for AI researchers. It's about understanding the incredibly rigorous, multifaceted, and constantly evolving work that goes into trying to make these powerful AI models reliable, safe, and genuinely useful for all of us. It's kind of the hidden engine driving the responsible side of the AI revolution, trying to transform intuition and hype into a more precise science.
Absolutely. It leaves us with a really provocative thought, doesn't it? As we start thinking about evaluating LLMs, not just on what they produce or how they produce it, but on their potential underlying cognitive properties through something like psychometrics. What does that mean for our own understanding of intelligence? What happens when we start seriously trying to give AI a cognitive assessment and maybe even measure its personality? It definitely gives you something to chew on long after this conversation.
It raises profound questions, not just about AI, but about ourselves and the nature of intelligence itself. Really deep waters there.
Indeed. So maybe the next time you interact with an AI model, take a second to think about the immense complex web of evaluations, the successes, the failures, the ongoing efforts that went into making it reliable enough, or maybe just reliable enough for you to trust and use. It's a field as dynamic, challenging, and fascinating as the AI itself.